Let's get going. So, welcome everybody. Thank you very much for coming. I appreciate you being here. I know that you have a lot of places you could be right now, so it honors me that you've decided instead to spend that time with me here today. We're going to go through a lot of stuff, and we don't have a lot of time to do it. So, as a result, I tend to go pretty quickly. I have a cold today, so I may blow my nose, I may sneeze, and this is why I'm not very good for handshakes right now, because they're just so dirty. But there's some things that should not be open sourced, colds are one of those things. So anyway, we're going to go through a lot of stuff today, and I encourage you to keep what's happening at a high level in your head, but you don't have to remember all the code. That's why we have GitHub. It's online. It's there for your own reference and your own edification later. So if you have questions, comments, feedback, whatever, I'm very happy to hear from you. I'm also online. I'm available and happy to answer questions. How many of you are on Twitter? Twitter. It's 2017. Twitter. Anybody? Okay, well, the rest of you, get on it. It's awesome. It's the new IRC. It's where all the stakeholders that drive the projects that you care about are today. So if you have questions, comments, feedback, whatever, don't hesitate to find us there. What about email? Email. Does anybody here have email? Anybody? Well, all right. That's a thing as well. And if you have questions, I'm happy to answer those as well. But keep in mind, I tend to be fairly asynchronous, bouncing around from one place to another. So expect some delays, yeah? A little bit about me, as was just well explained. I'm a Spring developer advocate on the Spring team. I have been now for almost 8 years. I've been a contributor to the open source projects. I am the #1, top ranked, most prolific, most visible, loudest, shoutiest contributor of bugs, but still number one. More bugs than any other developer on the team for projects like Spring Boot, Spring Cloud, Spring Integration, Spring Batch, Vaadin, Timeleaf Activity. Per line of code, more bugs. Very, very proud of something, So there's that. I'm a Java champion. I'm a Spring developer advocate. And as a part of that, I do my level-headed best to help people build applications that survive and thrive in the cloud. These days in terms of Spring, because that's kind of a thing and it works very well for this. So. As part of that, I did a training video. We talked about that for a second. I'm also working right now on this book called Cloud Native Java. Actually, before we sat down, I was, fighting through the last edits to one chapter that's going in that book. We're so close. And for those of you who are wondering, and I can see it in your eyes, I can see it welling up in your eyes, that bird on the book is a blue-eared kingfisher. It's a bird from the Indonesian Java Islands. It's a bird that is indigenous or native to the Java Islands. Now birds fly often in the clouds. So you would say that this is a cloud native Java bird. It's a bird that's native to Java that lives in the clouds. It's a cloud native Java bird. Never mind. It'll come. Give it time, it'll come. So there's that. And I work at Pivotal, and at Pivotal we have a lot of great open source software. You may recognize some of these technologies. How many of you have ever used Apache Tomcat? Apache Tomcat. All right, well, we're the lead developers and lead contributors to that technology, so you're welcome. What about RabbitMQ? RabbitMQ, the most widely used message queue in the cloud, including on AWS, where it outpaces even Amazon's own SQS. How many of you know RabbitMQ, yeah? So there's that. We are the lead developers on that. And of course, Spring. Spring's kind of a thing, right? I think it's going to be big one day. Don't know about now, but one day it's going to be big. And so we do a lot of great stuff, and we care about the open source. But let's be very clear. That's not why we are here. It's not why we spring out of bed every morning. Instead, what we care about is helping people go faster from concept, from product management all the way to production. And we realize that a lot of organizations struggle with this. They know that they need to go faster, but they can't because they are looking at their existing code base, their application that was written in yesteryear, 10 years ago, at a time before the era of cloud computing and the economics of cloud computing. They have these larger monolithic applications developed by large groups of people. And these applications are, hostile to change. Makes it very difficult for them to be able to maneuver applications into the cloud. There's a large group of people working on a large code base, so it requires a lot of work to make any small change. The cost of coordination becomes prohibitive. Synchronization across team members becomes prohibitive. So the answer, the instinct for a lot of people these days is to decompose these larger monolithic applications into smaller chunks of code. We call this small batch of work a microservice. A microservice helps organizations go faster. It helps them deliver faster because it reduces the size of the code base, which makes it easier for organizations to test. It makes it easier for us to understand what happens if you make a change, to isolate the impact of that change. But the problem is, when you move to this microservices architecture, you run into two big pains, two big problems. I call these the hemorrhoids of cloud computing, the hemorrhoids of microservices. Do you know what a hemorrhoid is? It's a real pain in the right? You run into two big problems. The first hemorrhoid that you have to address when you move to microservices is how quickly, from 0 to 60, can you stand up a production-worthy service, right? When you move to microservices, the logical consequence is that you're going to have a lot of small services, not one big service. And so all these things that you need to do, which are not business differentiating, they're not going to change your business impact, they're not going to make you a better technology company or a better business, they're not going to change your stock, they're not going to do any of that, but they are required to run the software in production. Things like security and observability and heartbeat detection and DNS and load balancing and scale out and all these kinds of things. How quickly can you do all of that? Most organizations, not yours of course, but most organizations, and I stress, I know it's not yours, but most organizations that I have seen have the terrible wiki page, the terrible, dreaded, nightmarish wiki page with 500 easy steps to production. That wiki page is the enemy of velocity. It is the list of things that we must do to build a piece of software that can run in production without hesitation. And that slows us down. If we have to do that, and if it's prohibitively expensive and time-consuming to do that, then we won't do it. It may just be easier, our instinct says, to throw everything back into the monolith. So we have to codify all of that. From where I sit, the best technologies on the market for those use cases are a platform, something like Cloud Foundry, and an operations-oriented and production-ready sort of framework like Spring Boot. How many of you know Spring Boot? Spring Boot is kind of a thing. I believe it's going to be big one day. Right now, it's only got 11 million or so unique downloads every month. But one day we'll get all 4 billion people connected to the internet using it. Anyway, so you need to care about that first hemorrhoid. The second hemorrhoid is once you've done this, you have lots of small collaborating services deployed across the network, communicating with each other across network partitions. And this, my friends, introduces complexity that you have to address. We have now a lot of different services. You've invited the complexity of building a distributed system into your lives. And we must be able to address these requirements. Because if you just build a lot of small REST APIs, you're just asking for more pain. You have done nothing but made your life more miserable. You haven't cared for the 10 fallacies of network computing. And so if you're ill-prepared to meet these requirements, to meet these challenges, then you're just going to make your life miserable. It's going to be complete hell. Don't bother. Just go back to the monolith. So today we're going to talk about this second hemorrhoid. How do we solve distribution problems? What kind of things do we run into when we build distributed systems? In order to demonstrate, I'm going to use, as I always do, my second favorite place on the internet, start.spring.io. How many of you know start.spring.io? Start.spring.io is my second favorite place on the internet after production. I love production. You should love production. You should go as early and often as possible. Bring your kids. Bring the family. It's the happiest place on earth. It is better than Disneyland. And if you're not already in production, then you can begin your journey here at start.spring.io. If you want for inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long, long night of alcohol abuse and PHP, start.spring.io. Bookmark it, keep it close to your heart. So what we're going to do is we're going to build a simple service, and I don't want to linger too long on the nature of the service or the domain model here. I'm going to build just a regular service, and we're just going to build it so we have something to work with, okay? So I'll use this. I'm going to call it the Reservation Service. I'm going to use Spring support for building web applications. I'll use Lombok, which is a compile time annotation processor. I'm going to use H2. H2 is an in-memory, embedded SQL database. Because it's in memory and it's embedded, it's going to lose all of its state on every single restart. Every time you restart the application, all the data will be gone. Very similar to MongoDB in this respect. All the data gone all the time for no reason at all. Just loses data all the time. Okay? It's almost a NoSQL, except that it has SQL. And we're going to use JPA, the Java Persistence API, to make it easier to work with this technology, and also because I make poor life decisions, so JPA. We're going to use Actuator for operational concerns and observability. We're going to use the config client for centralized configuration. We use Eureka for service registration and discovery, Zipkin for distributed tracing, and the REST repository support. Okay? Now I think that ought to do for now. Let me get this as well, just in case. Sleuth stream, yep, there we are. The sleuth stream stuff will come back. I'm not sure if we need the Zipkin client or that. Well, whatever, we'll leave there, okay? So I could, of course, elect to switch to the full version, and here you'll see a long, seemingly endless list of checkboxes, and I encourage you to peruse this list at your own discretion later on. But for now, let us just spend a few moments to address these three drop-downs. These drop-downs imply choice. And I agree that down here, there's absolutely a choice. Spring, by virtue of the fact that it works on top of Java and on the JVM, works just great with any language that supports annotations and objects on the JVM. So Scala, Ceylon, Java, Groovy, Kotlin, all fine, wonderful choices, and I encourage you to use whatever language you want. We've even pre-configured your projects for 3 of those choices here, okay? But here, my friends, here we have what I like to think of as non-choices, and I don't mean the bread. These are choices that are things that you could make, but that you shouldn't. In the same way that stripping naked and running in traffic is a choice. You could, but don't. But don't. So, for example, in 2017, what version of the JVM would you like to use? As both 1.6 and 1.7 are end-of-lifed, no longer supported, stale, past their prime, smelly, old, deprecated. As both 1.6 and 1.7 are no longer viable options, it would be irresponsible to continue using them in 2017. As both 1.6 and 1.7 have been deprecated for more than a year, it would be insane in 2017 to start a brand new project on either one of these. And WebSphere is no excuse. So, don't choose these. And then also we have the choice of packaging. And people get very confused by this. They don't know when and where to choose which. So I'm going to do my level-headed best here and now to explain. If by some crazy, freak accident of physics, some terrible, terrible tragedy of physics, where you find yourself somehow transported to the distant, distant past, far beyond modern help, then choose .war. But if you're here in 2017 with me, then choose .jar. This is a big part of my overarching guiding personal philosophy of make jar, not war. So I'm going to go ahead and hit generate. I'll create a new project here. I'm going to open this up in my ID, assuming it generates at all. Seems the internet here is a little spotty. Oh, that's so good. Come on. Go, go, go. Does that make it better? It doesn't make it better, does it? Okay, we got something. So, here we are. Unzip. Idea, reservation service, POM. And it doesn't matter what ID you use, my friends. Anything's fine. I'm using IntelliJ because it's, why not? But you don't have to use the professional version of IntelliJ. You can use the open source one. You can use regular clips, or you can use the Spring Tool Suite. You can use NetBeans, or you can use NetBeans plus the Spring Boot tools for NetBeans. All of them are great choices. I don't care. What about Emacs? Anybody here use Emacs? Are you here, sir? Emacs guy? No? Oh, wow. He's usually in all my talks. Every single one, in every city, in every country. I don't know how he does it. I say, who uses Emacs? And he raises his hand. And then he leaves. Then he goes to the airport and meets me at the next country and city. Has no point. Okay. What is that doing? Did I download a new version? Oh, they released a new version on me. Well, anyway, now's a good time for Q&A. Oh, rats. Sorry? Yeah.
Using the starters, it downloads everything that is there in the starter. Is there a way to specify that only download the jar which would be actually used in the code? There would be many jars which are downloaded along with the starter which we are not using by any mistake.
If they're in a starter, then they are meant to be there. They are being used by something. Whether you use it or not, that's different. Right? They released a new version of Spring Framework itself in the last 24 hours, apparently. So I am being caught by surprise. Let's see. 1.5.3, when did that come out? I can always just change it, but I might as well wait. Are there any other questions while we wait for this interminably long process? Yeah?
Does it matter for Cloud Foundry to have certain versions of the starters?
No.
I mean, is it possible that earlier version of Cloud Foundry can be used for the latest version of Spring Boot?
Of course. Cloud Foundry doesn't care about your application. It cares about processes. It takes your application, when you deploy the application to the Cloud Foundry platform, Cloud Foundry takes the application, if it's Java or .NET or Ruby on Rails or Node.js or whatever, and it creates a file system that has everything needed to run that application. In the case of Java, it downloads a JDK, and it sets up the RAM and sets up the class path and all this kind of stuff. If you give it a .war, then it'll download Apache Tomcat and all that. But basically, it's just going to create a file system needed to run that application, and then it's going to build a container, and it's going to deploy that container. It doesn't care about what version of Spring or if you're using Spring at all. It just sees that you have a jar with a public static void main or a .war and some servlet config, right? It doesn't care. So if you're using a .war and you're deploying, then it's going to use Apache. It's going to use Apache Tomcat 8, I think. 8 now. But you can even tell it, I want to use this older version by overriding the build pack. And the build pack, you can provide a Git repository revision. And if the build pack that you provide, instead of the one that's used by default, says use Apache Tomcat 7, then it'll use that. Right? Come on. Oh, this is so bad. CD, Reservation Service. F 634 kilobytes for a time library. And it's ironic because it takes a long time. Oh. Other questions? Sorry? Yeah, please don't. This is so awkward. I'm glad I got the faster Wi-Fi though.
Any specific reason that Spring doesn't maintain the backward compatibility?
What?
Spring doesn't maintain the backward compatibility. If we upgrade the version of Spring, really we find that some methods are gone or it's not backward compatible when we upgrade the Spring version.
With what? I don't even know where to start with that. What do you mean, with what?
Let's say I was using Spring 4.16.
Yeah.
Is it 4.6?
What? It's okay.
Moving down to 4.3.6 release.
Yeah.
Actually, some methods that were presented, that were available in the Spring 2.6, was not in there in the 4.6.
If you're using there's high-level interfaces, and there's the application context itself. These things are meant to be used by everybody, but if you're using implementation classes, engine component classes inside the actual framework itself, there's no guarantees about that. But Spring itself, if you take Spring Framework code from 1.0 and deploy it today, you deploy Spring 4.3, very likely it'll still work, right? Depending on what code you're touching. But if you're just talking to the high-level types, that should be fine. We have the best backwards compatibility story in the entire Java industry. I don't understand what you're saying, actually. When you look at all the other technologies out there, if you look at Java EE, for example, they have broken entire revisions of their specifications just like that. You know, like look at EJB, for example. EJB 2 to 3, completely broken. That's not the same, right, for Spring.
I was using the Spring data with the latest version, 12.5.1. So it was recommended that you should use 4 through 6 release.
Yes.
Try to use it 4 to 6.
Because they're using new features that are in the framework, and that's fair. Yeah. So that's what Spring Boot, by the way, is nice about. The nice thing about Spring Boot is you just use Spring Boot, and if it's using Spring Boot 1.5, then if you tomorrow say, I'm going to upgrade to Spring Boot 1.6, if it comes out, everything that is there will get upgraded with it automatically. And hopefully, you don't even notice anything that, like in a Spring Boot application, you don't deal with the low-level Spring sort of stuff, right? You're just dealing with component code, your business logic. Okay, speaking of business logic, our code is here, so let's get going. So I'm going to build an application. I'm going to build an application that manages entities of type reservation. So we'll say class reservation, and I'll say @entity. And I'll create a private long ID like this, and I'll give it a private string, and I'm going to call it reservation name. And this is JPA, right? I don't care about JPA. I just need something to generate a REST API with, right? So there's this, Alt-Enter. And I'm going to make this a Lombok data entity, and I'm going to say no args and all args constructors. I'm going to create an interface to manage instances of this data using a Spring Data repository. So if I say that this is a repository that manages entities of type reservation, whose primary key is of type long, and now I can actually create sample data. So I'm going to say sample data, CLR, implement, command line runner. Come on. And the command line runner, in turn, is just a callback interface. When Spring starts up, it's going to call this interface, and it'll give it a chance to run at the beginning of the application initialization phase, right? So I'm going to create a constructor there, and I'm just going to save some sample records here. I'll say stream.of Dr. Subramaniam. My name is Josh. Oh, wait, Scott. Right, there's Scott, Neil, etc., right? My buddy Rajdeep. Whoops. Come on. There we are. Comma. That's, what is that now? That's 1, 2, 3, 4, 5. We need at least 3 more. What's your name, miss? How do you spell it, my friend?
C-A-U-V-E-R-Y.
C-A-U-V.
E-R-Y.
Like this? Yeah. Very good. Nice to meet you. What about you, buddy? What's your name? How do you spell it, my friend? L-O? Like this? Very good. Nice to meet you. Miss, what's your name in the red? How do you spell that? V? Like that? Very good. Nice to meet you all. So, for each name, let's write the record to the database. Like so. And my constructor, my entity doesn't have the constructor for that, so I need to create that constructor here, right? I'm just going to say reservation string R, this, reservation name R, okay? Very good. And now I've got the records in the database, and I'll say reservation name.findAll.forEach, and all I'm going to do is I'm going to visit every single record that comes back using the system.outPrintln method here, okay? And there we go. So if we run this code, we should see that everything's working. But I want to build a REST API, right? So what I'm going to do is I'm going to comment out some of the things I don't need just yet for now. I don't want the Zipkin stuff, right, for example. So let's get rid of that. Oh, yeah, the tracing stuff isn't working. So comment out this. We don't want Zipkin for now. We don't want Eureka and config. Actually, that should be enough for now. Let's go ahead and try this at that. Take some water. All right. Very good. So there we are. We are happy records. all 8 of us. Now I'm going to build a REST API, so I'm going to make the repository a REST API, but using Spring Data REST, right? In order to do this, I need to actually go to my class path and add Spring Boot Starter Data REST, okay? Repository, oh, it was already there? Yeah, it probably already was, huh? Yeah, thank you, my friend. Good, so we've got that. Now I'm going to restart, and then I'll have a REST API. And I can use the REST API to talk to the database. And so that we have an application, it's got a REST API, it's got actuator, which supports operational concerns, right? So I can go to the application here, localhost 8080/reservations. I can see the APIs, the data itself. This is all supporting this is a pattern called hypermedia or HATEOS, HATEOAS. It's the hypermedia as the engine of application state. It's designed to promote self-describing services. That's all very well and good. I can also get insight into what the application is doing by going to the actuator endpoints. I can configure, for example, that the security for the actuator endpoint shouldn't be required by saying management.security.enabled equals false, and then restarting. And when I do that, I can see the results in the endpoint. This gives me the ability to see what's happening. I can see things like the memory, the heap, the non-heap. I can see the environment. I can see the trace, for example. I can see how many requests were made. I can see mappings. So I have the ability to see what's happening in the application. I can support observability on an instance-by-instance level. Now, what happens when I start scaling out? I've got one instance of one app, no big deal, all the configurations inside the application. I just changed it in that one property file. But suppose I want to start having more than one instance, or if I have more than one service. I run into 4 big problems, don't I? I don't want to keep my configuration, well, 5 big problems. I don't want to keep my configuration inside of the application jar itself. That's a problem. I don't want to have to recompile when I change things outside of the application, right? Things that are like from one environment to another, development, Q&A, staging, whatever. I want to keep those configuration values outside of the jar. The other problem I run into is when I do this, how do I support centrality? How do I keep it all in one place? I don't want to copy and paste configuration values from one place to another. Also, what about auditing and journaling? How do I see who changed what and when, and if necessary, to roll back? What about changing configuration while the service is running? How do I support that? And what about security? Suppose I have passwords or locators or credentials, things like that on the property files on the file system. I don't want that unencrypted. I want that to be encrypted and then symmetrically decrypted when it's injected into the client process, right? So for all of these reasons, this is a good start, but it's not good enough. We need something a bit more sophisticated. We could have a directory full of configuration and point all of the microservices to that same single directory of configuration. That would give us the centrality requirement. We could also use Git, or Git, for example. Don't use Subversion. You could, but don't. It's 2017. So you could use a version control system, something like that, to version control your configuration. That would solve the auditing and journaling requirement. You could see who changed what and when, and if necessary, to roll back. We could solve some of these requirements that way, but it doesn't solve the last 2 requirements. It doesn't solve the live reconfiguration. It doesn't solve the security. And for this, we're going to use a configuration server. The config server is a microservice that requires this. Come on, go. It's a microservice that manages configuration for us. So we're going to say that we want the config server. We're going to hit generate. Now, I'm going to open this up here, unzip config service idea. Well, here, maven -f config service pom install. Okay. Please don't, oh good, it's already there. Okay, idea pom idea config server pom.xml, and this is going to manage a directory full of configuration. And we can provide any directory we want, including one based on Git. So I'm going to use one here based on Git on my GitHub. You can get the same configuration. It's open, after all. And I'm going to clone this to my desktop here, okay? So desktop config. And I'm going to tell my config server that all microservices should get their configuration by talking to the config service. And the config service will, in turn, get the configuration by talking to the directory of configuration on the desktop. So home, desktop, config. And we also want to tell it to run and port 8888, okay? So let's spin this up. Now, our reservation service that we just built, it will talk to its configuration. It'll talk to the reservation, to the config server to draw its configuration. If we identify ourselves correctly, right? So we say Spring application name equals reservation-service. It's going to give it a name, and it's going to talk to the config server. It needs to know where to find the config server. So you can specify this value here, localhost 8888. Now, this is the default value. I specify this here because I want you to see how it's done. If you change the host and port of the config server, this will not work if you don't specify it, right? But as it is the default value, and as I have started it up on that host and port, I can comment it out and everything will be just fine. Now, if this microservice restarts, it's going to connect to this config server, 888, and it's going to ask for configuration. Woo. Oh, it can't find the directory full of configuration. Why not? Desktop, config. Here's this. Home. Oh, property values. Bash versus property. Awkward. I've been doing too much bash scripting. Oh, that's too fast. So, there's my directory full of configuration. I can see there's a property file called Reservation Service.properties with a message, hello world, and it's going to start up in port 8000. So the reservation microservice will get these keys and values. It will also get these keys and values. These are keys and values that apply to all microservices because it's in a property file called application.properties. So this is what happens first, and then for each specific microservice, you have a second file named after the microservice. So let's see, if we change our reservation service, it's going to use this message, and it'll start on port 8000. So let's now update the reservation service here to take advantage of that message that we had earlier, the message hello world. So message rest controller, okay, private final string value, awkward, oh no, okay, there's this. And I'm going to say that I want to inject that value from the config server. So we'll say message like this, okay? Now, I'm going to create an endpoint that just shows me that message, like so, message, string, read, and I'll return this.val. Now, message, rest controller, thank you. Now, this is good enough, but I can imagine wanting to change this value later on. So I'm going to make this bean refreshable. I'll say at refresh scope. So now if everything goes to plan, it'll start on port 8000 instead of 8080, and it'll inject that key called message into the controller. So localhost 8000/message. And voila, it seems to have worked. But this message is good, but it's not really great, right? We're not in just the world. We're in the best part of the world. We're in beautiful Bangalore. So let's update this config file here. I'll say Emacs reservation-service.properties. And I'm going to make this property value here a little bit bigger. Hello, Bangalore, right? Extra exclamation marks. Okay, good. Git status. Git commit -a. Updated, or even better, YOLO. Okay. Now, if I go to the config server, localhost, reservation service default, it sees the new value, but my microservice does not know what just happened. I have to tell it to refresh itself. And so I can call another actuator endpoint called refresh. I can say curl localhost 8000/refresh. And what I'm going to do is I'm going to make an empty HTTP post. So let's line this up, my friends. Let's line things up. What I'm going to do is I'm going to make an empty HTTP post on the left, and then as fast as my fingers will let me, I'm going to hit Alt-Tab to go to the other window, and then hit Control-R to refresh the browser. Okay. Ready? 1, 2, 3. Voila. Right? So what I did is I refreshed the configuration for that one component in situ. I didn't have to reload the application itself. I dynamically reloaded the configuration. This supports things like A/B testing or feature flags. I can now toggle certain bits of functionality in my system based on certain sets of configuration. By introducing the config server, we've also introduced a natural place to insert security. I can require security and authentication from the client to the config server, and from the config server to the directory full of configuration. This is one thing that's very useful in a distributed system, but we'll have to leave it at that. There's so much more to cover. So the next thing that becomes interesting in a distributed system is how easy is it for one service to find and work with others. In a dynamic cloud environment where services come and go, we can't rely upon DNS. It has a lot of limitations, particularly in a dynamic environment. Not just because of DNS itself, although that is certainly part of the problem, but because of the languages that use DNS. So for example, DNS itself, while an interesting protocol, all it can do is tell you where the service lives. It doesn't have the ability to answer the question, is that service alive? So if you make a request to a service that isn't there, you're going to block. Hopefully, you've all read and internalized and applied Michael Nygaard's amazing book, Release It. But if you haven't, then you've got timeouts in your code that are never going to time out. You're going to just wait there for replies that'll never come. So we want to be able to ask the question, is that service there? If not, I'll do something else. I'll degrade gracefully. Another problem is that clients typically do a bad job with DNS. Java in particular, which is now 21 years old, right? It's old enough to drink alcohol in the United States. Java has a lot of design decisions that made perfect sense in the 1990s, but that now, in a dynamic cloud environment, work against the grain. For example, it caches resolved DNS. So if you have a DNS load balancer, and you get an IP address from that DNS load balancer, Java is going to keep the first IP address, and it's going to call that IP over and over and again. It's not going to go back to the load balancer and get a new IP. You'll end up dogpiling that one instance. Can you undo this? Of course, you can configure it in the JDK, right? But the problem is that there's a lot of these assumptions in the network stack and in the JDK itself that work against the grain for this kind of dynamic, high sort of volatility environment. So we need to be aware of these things. And we still don't, even if we are aware of all these things, we're still not solving that other problem. The other thing is that we need more control in a cloud environment. We typically need more control over load balancing than your average load balancer will give you. Most load balancers have the ability to say, I want to do round robin load balancing, or I want to do sticky sessions. But what about something else? And what do we mean by sticky sessions, for example? When we talk about the HTTP servlet containers these days, most of them have the JSessionID cookie, right? So a lot of load balancers are smart enough to say, okay, I see that cookie. I'll pin the request from that client to that particular node. But what about an OAuth token? How do we say, this is an OAuth token coming from Josh on an iPhone? How do I make that request go to a particular node? Maybe Josh is streaming a video. Maybe this is Netflix. Where's the act like Netflix button on your F5 load balancer? Right? So we need more control over the load balancing algorithm in our code. We need to handle that on the client. So for all these reasons and more, while we could use DNS for some of these requirements, it's not really going to be a great fit, and it gets in the way. Not to mention, it's controlled by other teams. So we have to give up control to be able to manage that. Instead, let's use a service registry. Come on. Spring Cloud has great support for lots of different service registries via the Discovery Client abstraction. So you can use Apache Zookeeper, you can use HashiCorp Console, you can use Cloud Foundry itself, and you can use Netflix Eureka. I happen to be a big fan of Eureka for a couple of reasons. First of all, it's pretty easy to get running for a demo, as we are doing here. And that's important because I am very, very lazy. So I like lazy, I like easy, right? The other reason is that it's been used by one of the largest websites on the planet for years. So we know it works well, right? And that's actually the biggest reason, is that if you haven't made a choice, go with something that at least works for now, right? So let's Maven clean install. Come on, don't download the world. FreeMarker. What does Eureka have to do with FreeMarker? Well, anyway, in the meantime, we need to change our code to be able to talk to that registry when it comes back online. So let's activate the Spring Cloud Discovery Client abstraction. We'll say @enable Discovery Client. And the reason that works is because we have the Spring Cloud Starter Eureka Discovery Client abstraction implementation on the class path. So this annotation is going to register our application with the registry as soon as it compiles. Come on. Oh. Well, we'll wait for that. What we can do in the meantime, let's assume that eventually comes up, and then we can register application. Oh, come on, internet. Internet, please work. There we are. That was painful. Okay, let me rm .repository org spring framework boot spring boot starter FreeMarker. Okay. There's no way that wasn't corrupted. I'm just downloading it again. Okay, so assuming that comes back online, we'll get that working in a second. We're going to build a client that can talk to our reservation service. We're going to build a reservation client to talk to the reservation service by going back here and bringing in the bits that we need to build a REST API to talk to it. But we're not building just any client. We're going to build something called an edge service. So in order to do this, I'm going to use the config client, Eureka support, Zipkin client. I'll be using Hystrix, a circuit breaker. I'll be using Fane for declarative REST APIs, Actuator, REST repository support, web support, etc. And I think for our purposes, for now, that's enough. But of course, at the edge, you might also consider things like security and OAuth. But again, for our purposes, probably enough, okay? So down here, unzip reservation client, cd reservation client, Maven clean install. Oh. I wonder how big this is. Is anybody else on the Wi-Fi? Please, please, please. Seems like that's there. Oh, come on, baby. I mean, Atom, Palm.xml, 1.52. It's fine. Okay. There we go. And this is Atom, Palm.xml. 1.52 Maven clean install. Okay, so idea Palm.xml, there's this. We're going to set up the Eureka server very simply, just as we did before. So enable Eureka server. We'll go to application.properties. We're going to say Spring application name equals Eureka-service. Okay, and we'll spin this up, and then we're going to build our reservation client, which we've stood up over here. So cd reservation-client, idea palm.xml, and we'll do the same as we did before. We'll say, let's open up the property file, application.properties, Spring application name equals reservation-client, and what we're going to do in the code is the same as before, right? Same kind of basic toggle to activate the discovery client. So we'll say enable discovery client. Now that we've done that, we can also restart our service, right? That's aware of it now. That should be aware of it now. So if we go to, let's go see where our registry is right now. So 8761. Okay, there it is. There's our service registry. Our service isn't here yet, the reservation service. It's not available yet. Also, you'll notice very, very good mouse over. This took a long time to get right, but we have people on the team that did this. I'm very happy about that. It took a year to get that right. Anyway, that service is here. There's the reservation service. At this IP address, at this service ID, and at this port, it's now available for discovery. It's advertising itself for other services to find, like our reservation client, the one that we just finished standing up, right? So here's the reservation client here. And the first thing that we want to do is we want to call that service. We want to call that downstream service and make it easy for things that are talking to our edge service to find the downstream service, the reservation service. An edge service is the first port of call for requests into your architecture. The first service that things like your iPhone, your HTML5 device, your browsers, your PlayStations, your Rokus, your Xboxes, your refrigerators, whatever, it's the first service that those things outside of your system call, right? And this is a great place to adapt the outside world to the downstream services in your system. That way you don't have to reconfigure every single service each time you add a new service, or a new client rather. So imagine your HTML5 browsers. HTML5 browsers are very, very powerful today, but they live in a secure sandbox. That makes it very hard for them to call other services outside of that sandbox because of cross-origin request scripting forgery limitations. You can get around this limitation by adding access control headers to every single edge service. But this makes it very hard for the clients, or rather for the services, because they have to redeploy each time you add a new client that has a particular requirement. So instead of changing every microservice, you create an edge service. The edge service sits between your clients and your services. You can have an HTML5 edge service, an Android edge service, a PlayStation edge service, or whatever. Remember, today, almost everything has an IP address, right? In Singapore, the roads have IP addresses because they feed into a cloud for traffic shaping, not packet traffic shaping, like actual car traffic shaping, right? There are human beings with organs in their body that are artificial and connected to the internet. They are clients, right? There are all sorts of clients out there besides your boring Android and iPhone and HTML5 browser. So you never know what's going to come. And instead of trying to consider all of these up front, you just stand up new edge services. So we want this edge service to talk to our downstream service. One way to do that is to use a micro proxy. We can use something like Zool. Right? So I can say Spring Cloud Starter Zool. And Zool is a micro proxy. It'll automatically proxy all the downstream services in our registry by talking to the service registry itself and finding out what's out there. Let me comment out this bit here. I don't need it just right yet. Okay. And I can activate the proxy by saying @enable Zool proxy and then restarting. So that's one option. It'll just create a proxy. It'll route every request from the edge service to the downstream service. No questions asked. And that's fine. If you have no problems just having direct access to all your services on the edge, maybe you're done. But sometimes clients want a specific transformed or synthesized view of the downstream services. Maybe they want a composed view. Service A and service B form service C, right? They want to take the results and combine them in some way. And in this case, you want to do more than just blindly proxying the results back and forth. So here's our micro proxy, by the way, running on port 9999. So 9999 reservation service / reservations. You can see that as I make that request, it's using the service ID in the path to make a request to the downstream service. When it makes the request, it sends in the request the origin URL so that the JSON that gets generated from the reservation service actually reflects the proxy URL, right? So localhost 9999 reservation service / reservations is different from what's actually being generated at localhost 8000 reservations, right? Localhost 8000, 9999. Original edge, right? So that's one thing. The other thing you may be wondering is how does it know which instance to call? Right now I've only got one instance of the service in the registry. So yeah, obviously it's going to call that one. But what if I had 2 or 10 or 1,000? How does it pick? How does it load balance? And it does this thing using something called Netflix Ribbon. Netflix Ribbon is a client-side load balancer. It is basically a fancy comparator. It is meant to help you pick among server instances which node the request should be routed to. It does this on the client in the micro proxy code itself. There's no centralized proxy or load balancer that's doing this for you. The default algorithm is round robin, right? So it's just doing random round robin load balancing. But you can override that. You can provide your own load balancing strategy. You can do sticky sessions. You can do data center aware load balancing. You can do, the act like Netflix load balancing. You can do whatever you want, right? Based on whatever algorithm you want. You can load balance. You can unit test and version control your load balancing strategy, and that lives in your code base, not somebody's config file in a config server that you have no control over, right? So this is a micro proxy. That's good enough, maybe, but maybe I want to have a composed view. So let's go here and let's create a new endpoint. I'm going to create an endpoint that talks to my downstream reservation service. I'll call this the reservation names REST controller, okay? And my REST controller has one endpoint, called names or reservations names. And all I'm going to do is I'm going to return a collection of strings, just the names from the downstream service, right? So I could use the Spring Framework REST template. That's the HTTP REST client, and that's the workhorse of the Spring Framework for making HTTP calls. And that would certainly be a good enough choice, but of course it doesn't know by default about our client-side load balancing. It doesn't know about Ribbon. So we have to configure it to do that, right? I can say REST template like this, return new REST template. That would be certainly one approach, and I can say @load balance. That would be one approach, but I don't want to do that. That's a little too low level. Instead, I want to create a client easily based on the service. Again, if I'm moving to a distributed systems world, I want to make it as easy as possible for one service to call and work with another. So we can use something called Fane. Fane is a project from Netflix. In English, as you know, Fane means to pretend or to act as, right? So if you see an animal in the forest, and its poor little heart is beating really fast, and it's pretending to be dead so that you won't leave it, so that you won't bother it, so you'll leave it alone. It's like that, right? Poor little thing. It's pretending to be dead. It's not dead. It's feigning death, right? It just wants you to leave it alone. In the same way that WebSphere feigns usefulness. It's not really useful. It's not really useful. It just wants you to leave it alone. It just wants to die and move on, right? So we're going to use Fane. And Fane is on the class path here. Or isn't it? Isn't it? Fane. There it is, Fane. So what I can do is I can create a declarative client. I can say interface reservation reader. And here I'm going to say @Fane client. I'm going to load balance my requests, all going to the reservation-service. And I'll create an endpoint. I'm going to create a method that returns a collection of hypermedia envelope resources. Remember the hypermedia API that we built? The envelope object that contains the payload and the links is called a resource. So I need to take that envelope object, turn it back into a collection of resources whose payload is of type reservation, like this, right? So I'll say read, and I'll say request mapping get value equals reservation. So it's going to call, it's going to use ribbon to figure out which instance to call. It'll then make an HTTP get to /reservations, and it's going to take the JSON and convert it into a collection of reservations whose one field is the reservation name that we want here, right? So let's create that as a data. I guess I don't even have that, so Alt insert. There we are. Okay, there's my little DTO there. And now I can use that Fane client instead. I can say private final reservation reader R, and I can inject this into my constructor, and I can say return r.read.getContent.stream. Come on. Oh boy. Reservations, resources. Yeah, resources. It's a collection of resources, not a single one. Okay, so here we go. And we'll say .stream .map. I'm going to say take each one and collect just the name. I don't want the rest of it. I'm going to turn it into a collection of just the names. Remember, we're not going to keep all of the other JSON. It's just a very simple example. Now, I'm going to go ahead and restart this, and we'll see what happens. Now, what I'm going to do is, what's going to happen is oh, what's going on? Reservation. Oh, I need to actually enable Fane client. So we say @enable Fane clients, and we start it. So what's going to happen is it's going to make a call to the downstream service, and then it's going to make a request, and everything is going to be fine if we have one or more instances of the service. But if we have 0 instances of the service, what's going to happen here, my friends? Localhost 99 reservation names. That worked fine. There's our names in that one case. But what happens if we have 0 instances? It's going to blow chunks, isn't it? It's going to throw a big fat exception, and our poor iPhone users are going to get a big fat Java stack trace in the client. That's a terrible way to run a railroad. We need to do better. We need to understand that in production systems, things will go down. They'll fail. And so we need to introduce resilience. In this case, we're trying to load balance across 0. That's a bit like dividing by 0. And you all know what 0 divided by 0 is, right? What is 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
Basically. Don't make Cookie Monster sad. Prepare for the worst. Build robust production systems, oriented systems, right? So in this case, we can use a circuit breaker to create a fallback mode, right? So we can say @enable circuit breaker, and we can go here and we can say, I'm going to use Hystrix. This is the Netflix circuit breaker that we've integrated into Spring Cloud. We can use that to create a fallback path. So we say fallback method equals fallback. We say public collection of string fallback, like so. And in this case, all we're going to do is return an empty array list. Okay, just a better than nothing kind of use case. We just want to not throw chunks into the client if we can help ourselves. Now, so far we've built a system that is that takes advantage of centralized configurations, service registration, discovery, and we've seen how we can use the actuator to support observability on an instance-by-instance case. But what about in the larger sort of case? What about in the system itself? Remember, if I'm walking here in beautiful, beautiful Bangalore, is that the exact same experience functionally as looking at the Google map of Bangalore? Of course not, right? There's so much more that you can only appreciate if you're on the ground, here, among the people, among all the really, really great food, right? You can't appreciate that by looking at the map. The map is not the terrain. And the same is true for your production system. If you build a system, that the emergent behavior of that production system is not the same as what you can see in the map of your production system. All right, what is going on? We have 10 minutes, friends. What? We have 10 minutes. Relax. Okay, fine, bye. So anyway, the point is, we need to understand that the emergent behavior of your system is not the same as the actual system itself, as the architecture diagram of the system itself. So one way to capture that emergent behavior is to look at those circuit breakers. The circuit breaker is a connection from one node to another. It acts as a proxy, if you will, from one node to another. And we know that if a request goes through the circuit breaker and it fails to continue to go downstream, then that downstream service isn't working. So it's a proxy for monitoring that downstream service. So we're going to say Hystrix dashboard. We're going to use the config client, and we'll say Hystrix dashboard. Very good. And we also want Eureka for service registration discovery. Hit Alt. All right. Unzip. We're going to call this Hystrix dashboard. Idea pom.xml. And all this is going to do is it's going to monitor the flow of data through that circuit breaker that we used to protect our downstream service. And we can see that circuit breaker in action. Here it's working just fine because the service is available. But now if we kill our reservation service, where is that service? Here we are. You see, we get the empty array list, right? That empty array list shows us that we have something instead of nothing. High-performance websites do this kind of thing all the time. They'll say, oh, well, you called the search engine, but it's not available. Here are some machine-learned recommendations from across the web, etc., right? So is that up and running? Let's restart the reservation service. It'll heal itself. Hystrix dashboard is failing. Atom pom.xml. Okay. Clean install. Alrighty. Gonna close this one then. Idea pom.xml. Very good. So Hystrix dashboard, Hystrix application, @enable Hystrix dashboard, @enable discovery client. There's this. Okay, so we run this, and it's going to expect a service-end event heartbeat stream from the service that has the circuit breaker, in this case, the edge service. We can get that stream by going to localhost 99.99/hystrix.stream. That stream goes on forever and ever and ever and ever without end. It has no finish. And so one thing I would encourage you to keep in mind, my friends, is to never, ever, and I mean ever, curl this endpoint. So we're going to take that value and we're going to paste it in our circuit breaker dashboard here on port 8010 hystrix.html. Oops. Hystrix dashboard. Hystrix dashboard. Okay, in the meantime, the other kind of emergent visibility that I want to capture in my system is through distributed tracing. And so I can do this using Zipkin and Spring Cloud Sleuth. So I've got Zipkin UI config Eureka. I don't need the client, and hit generate. And I'll open this as well. CD Zipkin hyphen, oops. Unzip Zipkin hyphen service. CD Zipkin hyphen service. Idea Atom pom.xml. Come on. I'm going to change this to that. Idea pom.xml. Okay, so that Zipkin dashboard, or Hystrix dashboard, is up and running here. We can paste that stream into here to get the heartbeat stream. Click on this, and you can see that as I make requests on the left, localhost 8000 / 9999 reservation names, I can see the moving average trending ever upwards on the right. There it is, 23, 27, etc. So that gives me a visibility about the flow of data through that node. Now, the other thing I want to do is use distributed tracing. And distributed tracing, in theory, is very simple. For every request that enters or exits the system, trace it, right? Add a unique ID that we can then correlate later on. And you can do this using Spring Cloud Sleuth. And that's a good start, but I'm a big believer that you want to be able to visualize this kind of stuff to see it more effectively. So what I'm going to do is I'm going to add the one dependency I forgot, Zipkin server. Okay. There's this. And we'll say @enable discovery client @enable Zipkin server, and we'll go. So run that. Now, that's going to start on port 9411, and in order for us to talk to it, our reservation client and our reservation service need to be aware of it. So we need to have the Zipkin client on the class path. That's this one last bit here. Okay, so we'll add that, paste, go. That's the client, and then for the service, we'll have the Zipkin client as well. One more time. Okay. Nope. Come on. Now then, let's try it. Let's see. If we make requests to the Edge service, it's not quite up. Okay. One service registered, it started before the other one, but we can still use the dashboard. So we can say 9411, and we'll go here. We can see there's two nodes in the graph. We can see that if I click on one of these, it shows me the traces. I click on one of those, I can see the waterfall graph of requests. Let me try and, oh, I wish that, son of a gun. Oh well, if I had more time, this would have registered, and you would have seen both. But you can at least see on this case, you have just one instance. If we had more than one call in the graph, you'd see several lines, each as a separate call. So this shows you how to get emergent visibility or systemic visibility. So my friends, if we had more time, I wish we had more time, we could talk about all the other stuff that we haven't talked about, like single sign-on and security. We could talk about cluster coordination and things like this. We could talk about messaging and stream processing for eventual consistency. We could talk about higher order systems with Spring Cloud data flow for pipelines and so on. We could also talk about how to do integration testing across different systems with consumer-driven contracts and consumer-driven contracts testing. But as we don't have more time, so I just want to say thank you very much. I hope you liked what we talked about here. I certainly am a big fan. I'm wearing a Spring t-shirt and Spring underwear, of course. Of course, I liked it, but you don't have to take my word for it. There are organizations like Netflix, which is using Spring Boot and Spring Cloud at production scale. In a little bit further east in Japan, there's Rakuten.com, which is using Spring Boot and Spring Cloud and Cloud Foundry at production scale. Yahoo Japan is also using Cloud Foundry. In a little bit further east, but not as far east as Japan, in China, there's a small company called Alibaba. They're using Spring Boot and Spring Cloud at production scale, and they've talked about it loudly and proudly. Also Baidu, a search engine. These companies and these organizations, and many others besides, have great technology, great engineers, and the money that they need to support these requirements, and they still choose the pivotal stack. because it helps them get to production faster. And that is, at the end of the day, all that matters. Thank you very much for your time.
Thank you.